Welcome to Crush College Chemistry. Here we'll solve three basic problems among the concepts of atoms, ions, isotopes, and atomic mass units. And these questions are similar to the difficulty that you would see on a quiz or at the beginning of a test. Our first question is to write the isotope notation for molybdenum if it has twice as many neutrons as protons, and the number of electrons is 40. Now, there are many different ways to solve this problem. One of them is to look at the isotope notation and build from there using this explanation right here, but I recommend not doing that and instead starting with the periodic table. So we want to use the periodic table to figure out the number of each of the subatomic particles. It's clear that the number of electrons is 40. But we can also look right here and we can see, okay, so here's the chemical symbol of molybdenum, MO, here's the atomic number, which is also the number of protons, and our atomic mass of molybdenum is 95.95 AMUs. So with that, we know how many protons there are 42, and which of this info is relevant to finding the number of neutrons? The problem states that we have twice as many neutrons as we have protons, so therefore the number of neutrons has got to be 84. Now we are in a much better position to write the isotope notation. And again, we could have started with this diagram right here. This is the isotope notation, but it's less accident prone when we have all of these counts. This is the chemical symbol, this is the charge, this is the atomic mass, and this is the atomic number. So we know that the atomic number is 42 and the chemical symbol is MO. Now the question is, what's the charge and what's the atomic mass? So atomic mass, or mass number, is simply the sum of all the subatomic particles with significant mass, and that's the protons and the neutrons. Electrons have very small mass. It's just so small that we don't even take account for it. So it's really helpful because the mass of a proton and the mass of a neutron is 1 AMU. So the total mass of an isotope is simply the number of protons plus the number of neutrons. And we know that when we add 42 plus 84, we get 126. Therefore, this isotope has a mass of 126 AMUs. The charge acts in a similar way, where because, well, one, neutrons don't have any charge, so we can just ignore that, but a proton has a +1 charge and an electron has a -1 charge. So figuring out the charge of this ion, of this isotope, is simply subtracting the number of protons minus the number of electrons. And we know that we have 42 protons and 40 electrons, so it's got to have a charge of +2. Question number 2. How many neutrons does calcium have if it has 25 protons and a mass number of 52? Often our first instinct is to use the fact that the mass number is simply the number of protons plus the number of neutrons, and here's our mass number right here, and they tell us the number of protons, so wouldn't it just be 52 minus 25, and that would give us 27? But here's where looking at the periodic table first for isotope problems is so important. When we look at the periodic table for calcium, the atomic number is 20. The 20 is the number of protons it has. This doesn't have 20 protons. Does that mean that this is a special type of calcium that has 25 protons? No, because atomic number is inherent, it's characteristic of the particular atom. The atom, or the element I should say, is synonymous with the number of protons or the atomic number it has. What actually does have 25 protons? That's manganese. And so, this is a trick question. Question number 3. Calculate the average atomic mass of magnesium if it has 3 isotopes with consecutive neutrons, such as neutrons with 7, 8, and 9, where magnesium 24 is the most massive of the 3 and is twice as abundant as the other 2 isotopes. I have this little thing from my notes. In the equation for calculating average atomic mass of an isotope, we don't even really have all the information we need to be calculating this. And before we do those calculations, it states that we not only have 3 isotopes of magnesium, but they all have consecutive number of neutrons. The thing about mass number and neutrons of a particular element, they're pretty much synonymous. We know that magnesium has the same number of protons as magnesium, which has the same number of protons as magnesium. So if the neutrons differ by 1 each time, the mass number differs by 1 each time. And so we write the mass numbers of each of these isotopes in relation to each other. This has got to be magnesium-24 because it's the most massive. It has the largest mass. We also know X plus 2 is 24 based on how we've defined it. So we have magnesium-24, magnesium-23, and magnesium-22. We're not done with the problem, but we want to clearly state to our grader, these are the isotopes that we're using to get to our final answer. And so stating that as clearly as possible is going to help you get all the points possible. Likewise, we need to calculate the relative abundance for each magnesium isotope. However, given that we don't know that, we have to find it in a way that's similar to the way that we found the mass numbers of each of these isotopes. So we know that this has a certain percent abundance, this has a certain percent abundance, and so does this. And how can we turn this into a math problem? Well, we do know that because we're accounting for all 3 isotopes, it has to add to 100%. So we know that A% plus B% plus C% is 100%. One of the isotopes, the C%, is twice the percent of the other 2. So now we have a system of equations, and with a little bit of algebra, we solve for A%, for example, and we get that it's 25%. So if this is 25%, then this is 25%, and this is just twice that. And you check it out, and you see, yes, it does in fact add up to 100%. So these are the correct percents. Now, home stretch, we have to figure out what the average atomic mass of this magnesium element is, given the masses of the individual isotopes of magnesium and their relative percent abundances. And essentially what we have to do is we have to multiply these two sets of numbers together, and these 2 sets of numbers together, and these 2 sets of numbers together, and then collect it and add it together. When we do that, we get the average atomic mass of magnesium in AMUs, and our answer is 23.25 AMUs. Average atomic mass of magnesium, given these isotopes, magnesium-22, magnesium-23, and 24, in their stated abundances of this, this, and this, is 23.25 AMUs.